All right, let's talk about something that sounds super complicated but really isn't. Logarithms. Stick with me because I promise, by the end of this, you'll see they're actually pretty simple and, dare I say, kinda cool. Let's get right into it. Okay, so let's start with something we all know. 2 to the power of 3 is 8, right? Simple. 2 times 2 times 2 equals 8. Now, I want you to burn this little equation into your brain because it's going to be the key to unlocking everything else we talk about today. So what if I told you there's a totally different way to write that exact same thing? On the left, you've got your standard exponential form, but on the right, that's the logarithmic form. It looks a little weird. Log base 2 of 8 equals 3, but here's the secret. They mean the exact same thing. It's just two different languages for the same idea. And that's really the first big takeaway here. Exponents and logarithms, they aren't two different things you have to learn. Think of them like two sides of the same coin. You can flip between them whenever you want because they're just different ways of saying the same mathematical fact. So what is a logarithm, really? Well, it's just a way to look at exponents from a different angle. You know how an exponent answers the question, what do I get if I multiply this number by itself this many times? Well, a logarithm just flips that question on its head. And yeah, log is just what we say for short.
Okay, pay close attention because this next part is maybe the most important thing you'll hear today. There's one simple, single question that's like a secret key. If you can remember this one question, you can solve pretty much any basic logarithm you come across. It's the magic tree.
And here it is. The question is, to what power must the base be raised to get the argument? Seriously, that's it. Every single time you see a logarithm, you just ask yourself that one question. The answer to the question is the answer to the logarithm. It's the whole game right there.
All right, enough talk. Theory's one thing, but let's see this in action. We're going to do a few examples, and for each one, we'll use that magic question to find the answer.
Okay, first one up. What is log base 2 of 16? Now, don't let the notation freak you out. Just remember the question. So, let's translate it. We're asking 2 to what power equals 16? Okay, let's just count it out on our fingers. 2 times 2 is 4, times 2 is 8, times 2 again is 16. Hey, that was 4 2s. And there you have it. The answer is 4, because 2 to the 4th power is 16. See how that works? You ask the right question, and the answer just pops out. Let's do another one, just to make sure it clicks. How about log base 5 of 125? It's the exact same process, just with different numbers. So what's our question? 5 to what power equals 125? Well, let's see. 5 times 5 is 25. And 25 times 5? Yep, that's 125. So the answer is 3, because 5 to the power of 3 is 125. It's becoming pretty straightforward, right? Okay, now for a fun one. This one looks a little weird, but it actually teaches us a super important rule. What's log base 27 of 1? Let's ask the question. 27 to what power gives me 1? Now you might have to dig back in your memory for this, but remember that rule from exponents? Any non-zero number raised to the power of 0 is always 1. So the answer has to be 0. And that's a rule you can take to the bank. The log of 1, it doesn't matter what the base is always 0. All right, final example. This one's going to make us think a little differently. What is log base 4 of 2? So the question is, 4 to what power gets us 2? Now wait a minute, how can we raise 4 to a power and get a smaller number? Well, think about this. What's the relationship between 4 and 2? 2 is the square root of 4, right? And what's another way to write square root using an exponent? It's the power of 1/2. So the answer is 1/2, because 4 to the power of 1/2 is just another way of saying the square root of 4, which, of course, is 2. Pretty cool, huh? That's how fractions get into the mix with logs.
Okay, so now that you've got the basic idea down, we do need to talk about a few ground rules. Think of it like the fine print that makes sure logarithms actually work and make sense.
It's pretty simple. There are just 3 things to remember. First, the base has to be a positive number. Second, the base can't be 1, because that would be boring. 1 to any power is just 1. And third, the number you're taking the log of, the argument, also has to be positive. Those are the rules of the game. All right, next up, there are 2 special celebrity logarithms that you're going to see all the time. They have their own special names and notations. First, there's the common log. You'll see it written as lg of x, or sometimes just log of x with no little number at the bottom. Whenever you see that, it automatically means it's a base of 10. The other one is the natural log, written as ln of x. This one has a special base called e. Don't worry too much about what e is right now. Just think of it as a super important number in math, kind of like pi. So you might be thinking, okay, cool trick, but why do we even care about this? Well, the reason logarithms are so important is that they make really, really hard math problems simpler. They have this amazing ability to turn a messy multiplication problem into a simple addition problem. They're a fundamental tool. So understanding them isn't just about solving a new type of puzzle, it's about unlocking a whole new level of math.